Okay. So, tell me about cognition. So we had intelligence, which we tried to give a rough uh, definition for, let's say. And we figure cognition must be similar-ish. What do you think cognition is? Go ahead.
Maybe using our existing knowledge to generate something new.
Okay.
Like you said, intelligence was relating to something, relating to something past, what we already know, and predicting the future. So relating that, I think.
Okay, so maybe the kind of the ability to think or learn something like that to take past experiences or take whatever, take our current resources and make decisions or solve problems or think or something like that. So it's more of an active trait as opposed to an experience-based trait. So maybe the ability to think slash learn.
Acquire knowledge.
Ability to acquire knowledge, okay.
Use it to do something, to gain some understanding from it.
Okay, so, and I think we're all kind of saying the same thing here. So how does this play in to grand ideas of computer science? So far everything else has been pretty connected. You know, even with the intelligence piece, we were able to say that, okay, well, you know, intelligence is kind of a required piece. The human beings need to be involved in any sort of problem that we're going to solve using, any problem we're going to solve in computer science. Why does cognition need to be there? How does it relate?
Taking all the wealth of information and coming up with some sort of pattern for it, for maybe the stock market. Taking all past data and finding some sort of pattern to predict the future.
Okay. So how is that cognition but not intelligence?
What was our formal definition for intelligence?
Human provided ingredient that makes all programs tick. I don't know how formal that is, but I mean, clearly these two are very related, right?
Yeah.
I'm just trying to get us to distinguish them a little bit. As you might imagine, I mentioned that we're dealing with there's 9 grand ideas of computer science, and we have, I've said that each of our projects are going to be 2-week long. So we're only going to be able to do 8 of them. As you might imagine, cognition and intelligence are going to go together. I mean, they're pretty related things, and it's going to be, we're seeing it right now, even at the high level. How do we differentiate those guys? So we've kind of said that a human being always needs to be involved. We're solving those problems. Okay, so you know we get the ball rolling. Okay, so through our intelligence and our cognition, we are solving problems. Which aspects is the intelligence, and which aspects is the cognition? So cognition is kind of our ability to think or to learn, where intelligence is, do we have kind of the equivalent definition over on intelligence? You know, we've kind of just thrown we could almost throw this the same exact definition here on our cognition, in terms of it must be a special ingredient that humans bring to the table in order for that problem to be solved in the first place. Because we couldn't have thought of a solution or formulated a solution without a human being having cognition in order to bring that to the table. So this definition right here could really apply to both of those. So maybe the issue here is that we've done an okay job of defining cognition in general. We haven't necessarily done a great job of defining intelligence in general.
If we think of speech recognition,
Mm-hmm.
we can learn to recognize speech better. The intelligence part of that would be that there's sound waves that build up a word, and that you can take little tiny chunks of that and put them together to form a word. And then at the end, words are stored in some sort of structure. And then the cognition part would be taking that information and taking the input and seeing, does the output match, and then changing the inside of it, the neural network that they use to make it more accurate. The intelligence part is, what do we start with, what do we end with, and how do we work with those, whereas the cognition would be fitting them together.
Okay. Yeah, I like that. So let's see if we could so can we come up with an equivalent to that on the intelligence side? Maybe understanding the meaning of data?
Yeah. So what do we need to solve the problem?
Or if we're going to do this in the semantics of data. So what does data mean? And this is you might, to connect it to the other thing, ability to problem solve with data that we understand through our intelligence. Something like that. We understand it here, and then based on that understanding, our cognition allows us to now solve a problem, think about a solution, propose a solution, and between those two, can you have intelligence without cognition? And can you have cognition without intelligence? And you definitely can't have cognition without intelligence. But can you have intelligence without cognition? How?
Intelligence is general understanding what we, what we understand over a big picture. That is something very general, maybe. So yes, cognition is something, as you told, is after understanding it, implementing it in another way around. So maybe intelligence can't exist without the cognition.
But as far okay, fair enough. So we could say that it can exist, but the question is, does it exist? As far as we know, the only source of intelligence, as it relates to computer science, is the human, right? Is the human the only source of cognition as well?
I think so. But we can use intelligence to build cognition in computers, but we can't have intelligence without cognition. Cognition is how we learn, like the ability to think and learn, as we have right there.
Okay, so that's really where we're differentiating the idea of just having data. So otherwise, we can say intelligence is just having a big database of stuff and having them labeled all accurately. Intelligence is more than that. It's kind of having it in a form that we can then leapfrog from and actually solve problems. So cognition and intelligence go hand in hand. Okay? So both required things in these grand ideas. Okay. Complexity. What's this guy? What does it mean for something to be complex?
Walking and texting and talking to your friend at the same time.
Okay. So we can say that is a complex thing, but is that something that many of us could do fairly passively? Walking and texting and asking your friend where they want to go to lunch? I mean, do most of us think we could probably pull that off with some level of success while walking down the hall here? Does that mean it's not complex just because we can pull it off?
Complex is, I guess, a bunch of things that are detailed but are related to each other.
Okay.
So everything, for something to be complex, it all has to relate to one thing. So that walking with, while texting and talking to someone else, each of those individual tasks is not complex, but when you combine them together, they become harder to do because there's more tasks to get done, and they're related to the overall idea of walking while doing multiple things.
Okay. So kind of going off our last two, dealing with intelligence and cognition, is complexity a human-based trait, or is complexity something that describes a problem? Describes a problem. How does complexity relate to our abstraction?
All the steps added together, are the complex. That is the complex part. It is complexity. All of those parts working together to create the solution.
Okay, so if we assume that complexity means that something, when we say that something is very complex, that means it has lots of parts, or something along those lines, right? Okay, and one of the ways that we deal with that complexity is through abstraction. We simplify those parts at varying levels depending on how far we need to simplify it. Okay, do we always need abstraction? See, I think you're right. At some level, we're always abstracting. We might not necessarily notice it if it wasn't a big leap for us, right? But we're always trying to take something from the specific down to a simplified version of it for our understanding. So I think we're always abstracting. Now, does everything have a complexity? In computer science, how do we measure complexity? Time might be one thing. Okay, what's another? Memory, space. Okay. So we have a certain notation in computer science that we've historically used for measuring complexity. Anybody remember what that is? Probably you've seen it as it relates to like searching algorithms and sorting algorithms before. Big O notation. So something is order n or n squared or n log n, that kind of stuff. And that kind of gives us an idea of the, if I'm abstracting that, I like to think of big O as kind of being like maybe the number of comparisons that need to occur before a decision can be made. And usually when you give a big O, it's the number of comparisons on average. Okay? Or sometimes you can think about it from number of comparisons in a worst case versus best case, and then you get your average. But complexity is something that when we think about computer science, we kind of have a fancy symbolic way of denoting complexity. But is that something that really comes up all the time? When do we care about complexity in computer science? Okay, so wouldn't you say that you've written several programs before that crunches data? And in every single one of them, have you been concerned about complexity?
Yes.
Well, you're a math guy, so maybe. I mean, realistically, we get concerned about complexity when things don't seem to be running as quickly as they should be. Human beings, you go back to, we measure things in terms of time. That's usually our first step, right? We only think about memory when we run out of it. Right? Memory is only a problem if we don't have enough. Or if we have the most that we can get, and it's still a problem. Okay? So usually we're thinking about things in terms of time. Well, from a human being's perspective, we're not able to distinguish between fractions of a second. So if a program, is written extremely inefficiently and it takes 2 microseconds to run versus, 0.6 microseconds to run, we're not going to notice. We're not going to go and run off to the, complexity charts and see, well, is there some sort of fancy mathematical algorithm behind the scenes here that I could do to really, streamline this thing to get those, that 1.5 or 1.4 microseconds back. You're going to spend a lot more than 1.4 microseconds looking for that solution. Point is, we typically won't care, right? So complexity only matters when it matters. But is it always there? Every problem has a complexity associated with it. Some problems are more or less complex than others, but they all have complexity associated with it. So is it fair to say that complexity is something that's part of all problems in computer science? Might be more meaningful for certain problems than others, but it is part of all problems. So how could we come up with a general purpose definition for complexity? The amount of time and or space, or the
Lots of pieces and how long it takes to move them.
the number of pieces and how long it takes to move them. I don't hate that. How long or how much space? How long it takes to, well, I think we just do long in quotes that'll strike the right balance between space and time while still being sufficiently creepy. All right, leave it at that. All right. Creation. What's creation? Is it the act of creating? So what is creating? Is this another one of those human-related things? Kind of intelligence and cognition side of the world here? Is creation the same thing as those? Is it kind of the flip side? We use intelligence and cognition to formulate a solution. Fair enough? When do we use creation?
We're not doing it right now. We're not creating a definition for it.
Okay. But are we using intelligence and cognition to search for that definition? So what's the piece that we haven't done then?
The actual implementation.
Actual implementation. So really creation is related at some level to actually taking that intelligence and cognition solution and actually implementing it. Can creation be automated?
in some ways. Depending on what you're doing, you could. It could be.
And what you want to create.
Okay. It almost becomes like a recursive loop type thing, where it's it takes a human to start the process of creating a solution to a problem, but that solution might be to create other solutions. So almost chicken or the egg type thing. So might we say creation has to do with human implementation of a solution? So now we're going to go back through these, and we want to look at examples. What are some examples of algorithms? So now I'm kind of putting us in this, in this world where, so for instance, this week we're going to start with algorithms, because that's a pretty easy one to start with. We'll just go through these guys in order. And you're going to have to pick a topic related to algorithms. So we're going to talk about a couple of topics here, but you can pick whatever you want. And then you're going to do a literature search on that topic, which means you're going to go, you're going to kind of propose a question, or you're going to think about a particular algorithm, and you're going to go read 5 papers dealing with that algorithm. And you're going to create an annotated bibliography based on the 5 papers you read, summarizing each of those papers, kind of evidence that you read them, but also kind of giving you the, it's almost you're producing Cliff Notes. Do Cliff Notes still exist? Is this still a thing? So, you're reading the long-winded version, and you're summarizing it in a paragraph or 2, kind of as evidence that you A, read it, but B, were able to take, your comprehension was there to a point where you can actually spit back roughly what it said. Okay? And then, so that's what will be do for next week, is you're going to read the 5 papers. You'll write your idea paper, which is effectively like a page or a page and a half little thing that says, here is the algorithm that I'm interested in, and here's the specific problem related to this algorithm that I'm interested in. Maybe it's time complexity of something. Then you'll go and read 5 papers that deal with time complexity of that something. And then in the end, you'll be writing a paper, but your paper isn't going to be new research where you're creating some new conclusion. Instead, it will be either supporting or breaking down one of the papers that you did read, or even a paper you didn't read and you wanted to debunk it, or you wanted to support it using the 5 papers that you did read, something like that. So if somebody says that algorithm XYZ, which has this time complexity, can actually benefit from a parallel solution. For example, you could read some papers dealing with parallelism, as well as maybe even parallelism as it relates to that particular algorithm, and then draw a conclusion as to why that does sound plausible, that it could be faster through parallelism, as opposed to some things where you can bring in as many extra threads or extra CPUs as you want, and it's not going to become any faster. It kind of comes down to how many people does it take to change a light bulb, down to that end of things. So that's going to kind of be what our next 2 weeks looks like. So for next week, it's going to be the idea, pick an algorithm, and pick some sort of interesting problem related to that algorithm, or something involving that algorithm. Read 5 papers. You might have to kind of do this in reverse, right? You might have to look at what papers you can find related to the algorithm, and then read the papers, write your annotated bibliography, and then based on the commonalities between those 5 papers, you might come up with your idea paper that is some concept that's related to the 5 papers that you wrote, then you'll have a kind of a response paper based on the research that you read. Does that make sense? And we'll talk more about that next week in terms of what that paper should actually say. So, what are some examples of algorithms that you've heard of? You should have a lot to choose from.
Yeah, I mean, basically everything.
So I should just write everything?
Variable declarations one. That's an algorithm, isn't it? Or is it anything with addition, multiplication, subtraction?
Well,
SHA-256.
okay. So one of our encryption algorithms.
Yeah.
I mean, I think what you were going with is not unfair. But if you try to get too generic, you're going to have problems finding papers.
Yeah.
So yeah, picking a specific algorithm that has a name is probably going to be your safest.
What is it? The Mueller error code checking algorithm? That Mueller read error code checking? I don't know. He has to do research on it.
Oh, MD5?
Or, no.
I don't think so.
So we could probably say SHA-256 or other encryption. Okay, what about search algorithms? What search algorithms do you know of? So number one might be like a linear search. That's our easy one, right? Linear search. Just start going through, looking. Okay, so we have binary search. What's the difference between a binary search and a linear search? It can be implemented that way. Binary search is sometimes called a dictionary search. So the idea of a binary search is you're looking for a name in the dictionary. You open the dictionary to the center. Point at the name in the center. Is that the thing you're looking for? If yes, you're done. Found it. If not, is the name I'm looking for, does it come before this or does it come after this? If it comes before this, rip the book in half, throw away the right-hand side. I know it's in this half. Turn to the center of that half. Is that what I'm looking for? Which half does it come in? So it's a divide and conquer based search algorithm where we keep dividing our data in half and half and half and half and half until we finally get down to we're out of data to look at or we found it. Okay, as opposed to a linear search, which just goes through our data in order. So best case of a linear search is you find it in one check. Worst case in a linear search, you find it in n checks. All right, so it's a big, the average search time is pretty large. Right? You gotta get lucky in order for a linear search to be fast. Where on average, a binary search is going to be quicker because you're having the size of your data each time you check something. Okay, even though in some situations a linear search could be faster if the data you're searching for needs to be earlier on. But a binary search also has a requirement that a linear search does not. What requirement does a binary search have? Your data has to be ordered. That dictionary search doesn't work if the dictionary doesn't have the words in order. Okay. Then you're just kind of flipping a coin as to which half it might be in. you have to know what's going on. So a binary search would be an example of an algorithm. What about sorting algorithms? What sorting algorithms have you heard? Bubble sort, merge sort. All right, so those are some examples of algorithms. And there's tons and tons and tons of algorithms. So, if you're interested in algorithm stuff, you can do a search on, I'm sorry, if you're interested in like security stuff, encryption stuff, you can do a search on, maybe password encryption or credit card encryption and find some of the common algorithms that are used for that and maybe look into something along the lines of that. Makes sense? If if you're more into sorting of data or searching data, or even, database algorithms, kind of like some of the newer algorithms for handling NoSQL database queries, that kind of stuff. There's algorithms dealing with how can we efficiently search through humongous amounts of data. Those would also be algorithm stuff. Some of them, they all have names, but some of them were just named after the people that came up with it, that kind of stuff. Okay.
Another interesting one would be the algorithms for compression or decompression.
Mm-hmm. Absolutely. And also encoding. So if you're kind of an audio video person, you might be interested in some of the encoding algorithms for video, MP4, MP3 for audio. Some of the image compression stuff, TIFFs and JPEGs and PNGs, the differences there. I mean, those are all algorithms that generate that. Does that make sense? But every one of those took the grand ideas of computer science to come to that conclusion. So what we're zeroing in on is something that falls into the category. I mean, with any of these, with merge sort, there's certainly abstraction. There's all these other things, but we're focusing in on the nature that this guy is an algorithm. He's an example of an algorithm. Okay. What about abstractions? What are examples of abstractions? I think we kind of just mentioned a few. Is compression an abstraction? I mean, it's certainly an algorithm, but there's going to be overlap with all these things, right? So we're kind of finding what's a reasonable fit, right? So really, compression, we're taking all the details of a file, and we are representing it in a more simple way, a structured way. You could argue whether or not it's more simple. Certainly, we have to know, what it is. But you could argue that could be an example of abstraction, similar with the audio technologies, MP3 compressions and AAC, that kind of stuff. Movie compressions, these are all ways of representing data in, if you want to replace simpler form, smaller form. We use compression all the time so that things can, travel across the internet more quickly given the same internet speed. And then we rely on the technology on either end to handle the decompression. And that's why Netflix has been so successful. That's also why internet providers hate Netflix. I mean, how many of you are Netflix binge watchers? Depends on the time, the time of the year, but I mean, usually it's like cyclic, right? You'll like binge watch shows like for a month, and then you hardly watch Netflix for 6 months or something like that. But the idea is that Netflix is pushing a lot of data over your internet connection, but it's far less data than it could be because they're dealing with a lot of proprietary compression stuff, and then relying on your set-top boxes or your Apple TV or your Roku or your PlayStation, whatever it is, whatever you're using as your viewer, your client for Netflix, you're relying on that guy to handle the decompression. A good example of that would be how many of you have used Netflix to stream 4K content? Have you done a 4K stuff on Netflix? Well, so I recently got a couple of 4K TVs, and if I want to do Netflix in 4K, currently the only way to do that is through the smart TV software that's built into the TVs, the actual physical TV hardware. The streaming set-top boxes, which connect through HDMI, currently can't handle 4K because it's a bandwidth. I don't think it's a full bandwidth limitation of HDMI. I think it's a combination of the bandwidth of HDMI and the computation power of those set-top boxes. Where if you have it directly coming into the TV over the internet, it's not having to compress down to what HDMI can handle at one time. So you can handle 4K streaming using the built-in smart TV features of the TV without using a set-top box that's tethered to it over a cable.
HDMI 2.0 has 18 gigabits per second.
Yeah, it's not just the bandwidth. Well, 18 gigabits per second, actually, that uncompressed, that still would be a problem. I mean, that sounds like a lot, but 4K, I think, might be almost that. But the punchline is it's a combination. I mean, those if you have any of those a Chromecast or Amazon Fire Sticks, I mean, anymore they're not even like actual boxes like the Apple TVs are. They're actually just a USB. Looks like a USB stick, but it plugs into HDMI and is completely powered off the HDMI. I mean, you're not talking about high-powered computing devices. Those guys aren't going to have, some significant processing and memory power in them to do a lot of decompression. They're having to rely on, that's why you're probably only can do like 1080p or 1080i with a device like that, which might be fine for most things, but it is a limitation. All right, so specifically examples of abstraction, we can say compression. So instead of it being a specific algorithm of compression, the idea of compression is abstraction. Nothing says you can't then talk about specific algorithms, but the idea of compression is simplifying or modifying data into something that is represented in a smaller space. You could say audio formats, also a compression-based thing. Anything else for abstraction? You can look at things like data representation languages probably as well. Things like HTML, JSON, XML. It gets a little bit, if you really stick to that core foundation of simplification, you get it across a little bit of a blurry line there, I guess. But I mean, JSON, or kind of what you were talking about earlier with your human-computer interaction class, where you were talking about different ways of modeling interfaces, interface modeling languages, UML and stuff like that. These are ways of representing data. You're not necessarily simplifying the data. In fact, oftentimes you're adding to it, right? But you're adding meaning in a simple form rather than get it too bloated. So it's probably fair to say something like JSON or UML as an example of abstraction. What about automation? And the main reason for doing this is you guys are going to have to kind of pick your topics as we get to each of these weeks. So, we'll probably revisit these at the beginning of each of the 2-week periods so we can kind of zero in on what you might want to look at. But this at least gets you started, the wheels turning, thinking about things. So dealing with automation. What are some examples of automation in computer science? I think a common thing now, and kind of the cool kid right now, is like self-driving cars.
Mm-hmm.
I mean, Wouldn't you be interested in kind of what's involved? I mean, part of this isn't just like, the research aspect. It's also about learning about things that you might be interested in how they work. Like every one of us in here has heard of self-driving cars, right? We've seen all the news reports about Tesla, and we've seen the little Google cars, and we kind of have this idea. There's cameras and radar. There's sensors and stuff, right? But maybe a couple of you know, but I certainly don't. I don't know the real nitty-gritty details of how it accomplishes what it accomplishes. I assume it's got all sorts of sensors that are paying attention to way more things going on around the car than a human typically does, and then it's making decisions very quickly based on all those inputs. But how does it actually work? What are the various algorithms that are out there that maybe the competitors, maybe there's collision avoidance algorithms that are in competition with each other right now, that maybe one works better for certain situations, another one works better for other situations. I saw a video, I think a couple weeks ago on, I think it was on Reddit, but it was from YouTube, of a Tesla car that predicted an accident before the accident happened. It was a dash cam from inside of a Tesla car, and another car switched lane. The Tesla wasn't involved in the accident, but so the accident happened, like, let's say 2 cars ahead. Before the accident actually happened, the Tesla reacted. The Tesla slowed down. No cars had hit each other at that point. But the Tesla, whatever it did, it figured out trajectory, like those dudes are going to be in the same space soon. So we need to do something so we're not part of that. But it was fascinating to read about it. So how often do you read about things in technology like that where you kind of have a clue-ish kind of how it works, but you're really maybe interested in how it actually works under the hood? I guess pun intended, dealing with cars, but so I think self-driving cars would be a cool. If I were doing this, I would probably pick something with self-driving cars for automation, some aspect of it. Maybe it's, I would look into it and figure out what are the different, kind of areas of, accomplishing self-driving. Because obviously, I think they exist now, in prototypes and research and stuff, cars that are completely autonomous. But what's actually out in the roads for consumers today aren't 100% self-driving, but they're self-driving to an extent. Like I haven't been in one, but my understanding is that, when you go on the interstate with a Tesla, you can pretty much push autopilot, and as long as you're staying on the interstate, I don't think it's taking exits and stuff for you, but if you're going down to the Keys and it's, 117 miles on one road, you push the autopilot button and it makes sure you don't hit stuff. I don't know if you set the speed or it uses GPS to figure out what the maximum speed, or you can tell your Tesla to speed. That would be pretty crazy. You think about some of those drivers down in Florida, I always wonder how they don't get caught.
Mm-hmm. They never do.
Keep going with what?
Going like 100.
Yeah, I mean, you'll see these sports cars down in Florida, and I actually saw it. He should have got caught, and he didn't. It was, I don't know what kind of car it was. Some expensive looking sports car blew by me on Commercial Boulevard down there going, he had to be going 100, something like that. And a cop on a motorcycle blew by me going the same speed, following him. Never pulled him over. I wonder if the other one was an undercover cop, maybe. If that's possible, that might be could be that scenario. But I don't know if you can tell Teslas to speed. Does anybody know anything about how Teslas work?
Wouldn't you set is it not setting cruise control?
I don't know. I'm not sure how it works.
I bet it would probably.
Like, can I set the cruise to 90 and just say, don't hit stuff? Because I know they'll switch lanes. I mean, the Teslas will switch lanes and pass people and stuff.
Really?
Oh, yeah.
Well, I didn't know that. I thought you had to control that.
Mm-mm.
Oh, wow.
I'm almost positive of that. So can you just say, I want to go 90, don't hit things? And it'll just maintain 90.
No available lanes.
That's cool. I didn't realize my cousin helped.
self-driving cars, I think, would be a cool example of automation. What else? Any other examples of automation? I mean, so I'll throw another example out there, something that I am, I mean, so, some of you who know me, I know this is the first time we've met, but I'm a very avid golfer. So I was not lying when I got your phone call on a golf course. I'm an extremely avid golfer. So golf simulators, this idea of automating the flying of a golf ball when you're inside of a contained room instead of being out there on there's a couple different technologies, some using cameras where they actually are measuring the ball and impact, some using sensors where they're measuring the actual club face of the golf club. So I think golf simulators would fall underneath the idea of automation. Similarly, if you're a tennis fan, I've seen this used pretty heavily in tennis. What's the actual technology called? It's got a brand, but I'm just going to say tennis call review.
Oh, I know what you're talking about.
This is funny. Wait, I'm going to do something here. Magic bar.
He gave
me the tennis emoji. That's an emoji, right? Yeah. Nailed it.
Pretty cool. You talking about when
gimmicky, right? Cool for 2 seconds. Yeah. So like in tennis, you can challenge calls, and it's only in certain stadiums that have the technology. But it automatically calls the ball in or out. It's not like in football where you can challenge a call and the refs go and review it, look at it from a bunch of different angles, and ultimately it's a human being making the decision. In this thing, it's completely automated. It tells you whether the ball that you thought was out was actually in, that kind of thing.
Kind of like the angle and like the little shadow.
Yeah, the shadow of the ball where it actually compressed. Did it touch the line? So tennis. Line calling, let's say. I don't know why I can't think of the name of the technology.
I've never heard of the name of it.
Yeah.
Hawkeye.
Yeah. All right, so tennis line calling might be another example of automation, but things along those lines. So if you start thinking as we kind of lead up, and we'll do these in this order, so you'll kind of know what's coming up. You can lead up to it. So those guys would fall into that category.
The new Tesla autopilot update will not let it speed on autopilot.
The new one. Apparently we had a couple of no lanes available issues. Are there any Tesla motorcycles yet? That seems like that would be terrifying. Because riding a motorcycle, there's similar to the whole walking concept, right? You are balancing whether you realize it or not, right? So if the bike is making decisions for you, you're not really shifting your weight in sync with. So I guess it just has to go really fast to keep you up with centripetal force.
It'd be like
Is that centripetal or centrifugal?
Centripetal doesn't exist. Yeah, it's not. Doesn't exist.
So it's centripetal. What's the alternative to that? There's another one.
Centrifugal.
So yeah, that's what I was looking for. So that's when stuff goes out.
Yes.
Centripetal is down. Is that right?
Yeah, it's an acceleration on the inside of the curve.
There's one of them that they thought that it existed, and then did tons of tests and stuff. And they realized
They tried it on a mouse and nothing happened or something.
like the certain kind of force that they thought was there doesn't actually exist.
I gotcha. All right, so information. So what are some information examples? So this could be some of the things like JSON or specific file formats or data representation stuff. So data representation, maybe it's more of the idea of data representation, which then allows you to go to a specific idea. So it would be less about JSON. Well, I guess information could be JSON as a tool for data representing information, or it could be a JSON-based data representation to represent something very specific. Because JSON is actually JavaScript object notation, so it's JSON wasn't invented. It wasn't invented to be used for what we use it for today. It was invented to make JSON object-oriented, or to make JavaScript, rather, object-oriented. It allows us to represent objects using a notation in JavaScript. So various data representation stuff. This could also be file formats. So you could look at proprietary file formats versus open file formats. Anything else with information? You could also do streaming. Streaming technologies would certainly fit into this category, which then brings things like compression right back in. You know, so you pretty easily we're starting to see here that all these ideas are really related. You know, so you really use the top level idea to kind of get you in the door, and then you see that, oh, well, this could really fit in these three other categories, but it probably fits best here, but it could have fit there as well. So hopefully on a weekly basis, you're not too pigeonholed into picking something horribly, I guess, again, pun intended, horribly abstract, that you can actually pick topics that you're truly interested in. Somebody has to do the self-driving car stuff, because I want to know how that works.
Apparently it's only undivided roads where they restrict your speed limit.
Oh, otherwise they don't? What? How could they make an argument to not restrict your speed limit? Like, what's the argument to say that, oh, it's okay for you to set your Tesla to go 90?
I don't know how much they set it there. Well, it does adjust to traffic that you're around.
Yeah, because obviously.
But for undivided roads, they're saying it's not as safe. That's a situation where you should be in control instead of their autopilot.
Wait, so you're saying you can't autopilot on an undivided road, or you can't set
It
the
will,
speed?
but it will.
It will with limitations of speed,
Yes.
but they're encouraging you to be prepared
Yes.
to take
They're
control.
saying if you want to go above the speed limit, that's on you. You drive the car.
Ah, gotcha.
So just put cruise control on.
But if you're on divided roads, then it's
Free game.
then
I don't know.
they'll take care of it.
You gotta think, the only thing you're gonna hit's in front of you, right?
Yeah, I don't know. Would that? I just amazes me, that we're seemingly close to this idea of like literally getting into a car, putting in your GPS where you want to go, and going to sleep.
My cousin told me some pretty cool stuff.
Apparently, you can't go over the speed limit unless there's a car in front of you to say that yes, traffic is moving at this speed.
Oh, so it basically keeps up with traffic.
Yeah.
Okay, I gotcha.
Rather than forcing you to only go.
So just get someone going 100 in front of you.
All of a sudden, then you're gonna read about this at some point when the self-driving cars become very popular. A lot of people have them. You're gonna start having these guys like fall into patterns, where the cars are like pacing each other, and they just keep one-upping each other. You got these cars going 230 miles an hour, like on residential roads.
Don't worry, it's safe.
Yeah, except for
Child runs out. Ooh,
What channel?
new TV, new monitor.
oh, is it?
Yeah.
Oh,
It's not
very
a
nice.
big bulky one anymore.
I don't get the point of those, anyways.
I don't either.
Well, no, I mean, I've never used them. I mean, are they effective?
Not those. The ones in 118, a little bit, because more of it's, I guess, angled.
I mean, I guess if you sat like right up here, you might have better view there than at a sharp angle onto the screen or something. But
Yeah. But I mean, that isn't even angled right for that then.
yeah, it's just there to look like
Yeah.
it's a smart room or something.
Yeah.
You probably installed it, didn't you? Are you lying?
I'm not.
You
I haven't even tested to make sure that actually worked with the setup, but
It looks nice. You don't even see what brand it is.
it's Sony.
Probably proprietary plugin as well. All right, so leave that for information. Probably got flexibility there, I think. Interface could get kind of interesting.
Ooh, this one's actually, my cousin helped with some of the designs for the HoloLens with like the hand gestures.
Okay.
And she
all right.
built it with us, and that was actually really interesting.
Like that, right?
I think it's only LENS. There's no E on it. But it might even be spelled different. It's
Whatever.
HOLO.
HoloLens, hand gestures.
HOLOLENS.
And, you know, we had hand gesture type stuff with like the PlayStation, whatever that thing was called. But, you know, so various types of interfaces. So that would be an example of HoloLens, Microsoft VR dealy. What else for interfaces? It's who? Augmented reality, yeah. I mean, you could still deal with some of the data representation stuff. She mentioned things like UML representation languages for representing interfaces. I mean, if you look at how iOS or Android interfaces are built, they're both XML based. Android makes the XML obvious, where Apple hides it from you, but at the end of the day, it's still a zip file and it's still an XML format. So, you know, you can do XML. Well, here, let's just say Android / iOS interfaces. Say things like HTML, CSS. Those are all interface type solutions. Along the lines of even you know, common things, you could look at stuff like Angular. So web technology where your interface is very active. It's linked to variables behind the scenes. You can actually link it to a database as well. So that's a kind of a modern web technology that is kind of an interface-driven type of thing. All right, what about intelligence? And we're going to couple these together, intelligence and cognition together. So let's have our examples for those kind of together.
Would Watson be one?
Actually, not really by our definition, but it's probably not unfair. You know, Watson is kind of a, you know, it's IBM's data mining hot. Yeah, right. So, I mean, it's really a intelligence or cognition approximation tool. You know, but since we're trying to pick things out of it's going to be hard for us to find things. I mean, you're going to have to look at psychology papers and stuff. So if we're kind of still living in the world of computing, to kind of stick with these guys, you might look at things like IBM Watson or Siri. Siri or what? Alexa, who's Cortana.
Viv.
Who?
Viv.
Who's that? Sony?
The maker of Siri started making it, and it's
Like that?
yeah, like that. It's better than any of the other ones so far.
So the folks who made Siri that Apple then purchased, those folks have then continued on not using the stuff that they sold, but based on what they learned using their cognition, developed.
I think Samsung owns it now.
Okay, so they sold it again. Smart people. So they sold their original stuff to Apple with Siri. Then they came up with something better than what they sold, and now they sold that to Samsung. So do that again.
I think they're well off.
I've always wondered that. And that kind of that's actually even related to some of the stuff in here. At what point? What's your motivation to keep making stuff? Like once you've made enough, like in terms of dollars, I guess. I mean, well, for me, I mean, I'm bored.
Yeah.
I mean, why do I keep teaching? I teach because I would be bored otherwise. I mean, you can only do so much.
You only golf so much.
Yeah, I mean, I'll tell you what, so I golfed 34 straight days, and there was at least 10 of those days that I just wanted to make sure the number racked up. I did not feel like being outside on a golf course. My hands were swollen, my back was killing me. It's like, I can't break I can't lose the streak.
Only 9 today.
So it was remind me at the break. I want to tell you about a pro. Let's actually take a break now. We're at an hour, but so under intelligence and also cognition, you might look at some of these things that are really more of an AI type thing. I think that's going to be the best bet for papers, things that fall into that category, even though that deviates a little bit for how we fit it into grand ideas of computer science, because really the human side of it. But all right, so let's do that.
I guess it's kind of how they're trying to make the human side of it.
Yeah. So it's not true intelligence or true cognition, but it's
closer to getting computing right now.
Yeah. All right, so let's take about a 10-minute break. I'll get this video uploaded.